Good morning students, welcome to the session. In this session we are going through the next chapter, that is differential equations of second and higher order. Differential equations of second and higher order. So in the previous classes we learned about the differential equations of first order and first degree. In the first order and first degree we learned about the methods of solving differential equations of first order. We learned about these all in the last chapter. Now in this chapter we are learning about the differential equations of second and higher order. More than the first order one, with the type of equations we are solving here. So here we are considering a general equation of nth order, general equation of nth order is of the form d power ny by dx power n plus a naught into d power n minus 1 y by dx power n minus 1 plus a1 into d power n minus 2y by dx power n minus 2 plus a2 into d power n minus 3y by dx power n minus 2 n minus 3 plus and so on, plus an minus 2 into dy by dx plus an minus 1 into y is equal 0. Not 0, this is some function, let it be q of x. Because of that here x is an independent variable. General equation of the nth order is of the form d power ny by dx power n plus a naught into d power n minus 1y by dx power n minus 1 plus a1 into d power n minus 2y by dx power n minus 2 plus a2 into d power n minus 3y by dx power n minus 3 plus and so on, plus an minus 2 into d power ny by dy by dx plus an minus 1 into y is equal q of x. This is called general equation of the general differential equation of nth order. So this one we will write in operator form. What is an operator here? Here derivative is the operator. So d of y means dy by dx, d square of y means d square y by dx square, and so on. D power n of y means d power ny by dx power n. Like this we are replacing all with respect to the operator d. Then this equation changes as d power n of y plus a naught into d power n minus 1 into y plus a1 into d power n minus 2 into y plus a2 into d power n minus 3 into y plus and so on, an minus 2 into d of y plus an minus 2 into d of y plus an minus 1 into y is equal to q of x. So don't consider this equation. This is the operator form. In these are all common term is y. Take out that one from this, from all terms. Then this one is of the form d power n plus a naught into d power n minus 1 plus a1 into d power n minus 2 plus a2 into d power n minus 3 plus and so on plus an minus 2 into d power d. This is the plus an minus 1, all terms having the common term as y, which is equal to q of x. And here a naught, a1, a2 and so on, an minus 2, an minus 1. These are all either constants or function of x. This one is also same. So this one can be written as f of d. Because of that, this total one is a function of d into y is equal to q. This is our equation. So f of d into y is equal to q is the general equation of nth order operator form. So this equation having solutions. What are those two? This equation having two solutions. One solution corresponding to the equation f of d into y is equal to 0, and another one is f of d into y is equal to q. So corresponding this solution is called complementary solution. Complementary solution. Corresponding to this solution is called particular solution. So this equation one having two solutions. One is complementary solution, another one is particular solution. Complementary solution is related to the equation f of d into y, right hand side value is 0. That becomes complementary solution. Another solution f of d into y is equal to q having a solution that is called particular solution. So complementary solution is denoted by yc. Particular solution is denoted by y2. If any equation having two solutions, then sum of those two solutions is again a solution. So the general solution to the equation 1, general solution to equation 1 is y is equal yc plus y. Yc is called complementary solution, Yp is called particular solution. If coming to this first equation, if the right hand side value is 0, then this equation having only one solution, that solution is called complementary solution. And q is equal to 0 means this equation 1 changes as homogeneous equation. So 1. If q is equal to 0 in equation 1, then equation 1 is called homogeneous equation. Equation 1 is called homogeneous equation. What is that equation? F of d into y is equal 0. So this is corresponding to the complementary solution. In this case, complementary solution becomes as a general solution. So there is no need to evaluate particular solution. When we are not evaluating particular solution, if the given equation is a homogeneous equation. When you are saying that it is a homogeneous equation, if the right hand side term of equation 1, what is the right hand equation 1? F of d into y is equal q. So in this equation, the right hand side term is 0, then that equation is said to be homogeneous equation. So if right hand side not equal to 0 in equation 1, then it is not a homogeneous. So in this case, equation 1 is what? F of d into y is equal to q. In this case, we have to calculate two solutions. One is complementary solution, another one is particular solution. This becomes the general solution of the given equation. So, in the evaluation of the complementary solution, having arbitrary constants. This is very important point. How many arbitrary constants existing in complementary solution means depends on the order of the function f of t. If the order of the f of d is 2, then this complementary solution having 2 arbitrary constants. If the order is n, then the solution having n arbitrary constants. And coming to the another point, particular solution does not having arbitrary constants. So in the evaluation of the particular solution, you will not get the arbitrary constants. In some cases, this particular solution calling as particular integral. So particular solution or particular integral, both are same. Complementary solution having arbitrary constants, particular solution does not having arbitrary constants. These two are very, very important points. Now we are going through the how to calculate the complementary solution to the given equation. That one we are learning here. So evaluation of complementary solution. Evaluation of complementary solution. Evaluation of complementary solution. Very, very important one. How to calculate the complementary solution for the given equation? What is the given equation? F of t into y is equal to q. So, after taking this one, complementary solution corresponding to the value f of d into y is equal 0. So, for this, we are writing auxiliary equation. How we are writing auxiliary equation? In this equation, replacing auxiliary equation calculating by replacing d as m and y as 1 in this one, then we will get the auxiliary equation. That means d as m and y as 1 is equal to 0. This is called auxiliary equation. What is the order of this f of d? F of d is of nth order. F of d is of nth order. Then auxiliary equation is also nth degree. Based on that, we will get nth degree equation. Next, after getting f of m is equal to 0, if you are solving this nth degree equation, you will get n roots. Let m1, m2, m3 and so on, mn or the roots of equation, or the roots of equation, or the roots of equation. Based on these roots, we are writing the complementary solution. So see this. Here some points you have to remember. So what are the roots? m1, m2, m3 and so on, mn are the roots of the equation. So right here, roots, solution. What is the solution? Complementary solution. Complementary solution. First case, m1, m2 and so on, mn or real and distinct. Real and distinct. What is the meaning of this? These are all roots or real roots and they are all different roots. In this case, complementary solution. How many roots? N roots. So complementary solution is denoted as YC. So write this one YC here. So complementary solution is C1 into e power m1x plus C2 into e power m2x plus C3 into e power m3x plus and so on plus Cn into e power mn into x. So n roots are real and distinct. So for distinct root, for every root we are writing complementary solution. For m1, C1 into e power m1x. For m2, C2 into e power m2x. For m3, C3 into m3x. Plus and so on. For mn, Cn into e power mnx. So if m is the root, then what is the complementary solution? C into e power mx. So here in this equation, x is the independent variable, and that's why here I got x. If y is the independent variable, I will get at that place as y. So this is for first case. Coming to the second one, two roots are equal. m1 is equal to m2. Remaining are distinct. m4 and so on, mn are distinct. That means in obtained roots, two roots are equal, remaining are distinct. Then the complementary solution is C1 plus C2x into e power m1x. So C1 constant, C2 constant. Two constants obtained here. Because of that, two roots are real and equal. So these two are over. Remaining roots are m3, m4 and so on. M. For those roots we are writing complementary. So C3 into e power m3x plus and so on plus Cn into e power mn into x. Coming to the third one, if three roots are equal, m1 is equal, m2 is equal, m3. Three roots are equal and remaining are distinct. Or distinct. Remaining are and so on, m6. Comma, m6. M7 and so on, Mn are distinct. In this situation, three roots are equal. Corresponding solution C1 plus C2x plus C3x square into e power m1x. 3 roots are equal. If 4 roots are equal, c1 plus c2x plus c3x square plus c4x cube plus and so on. In plus c4 into e power m4x plus and so on plus cn into e power mnx. Coming to the next case, m1 is equal to m2. This is one set of roots are equal. Another set, m3 is equal to m4. These two are equal. Remaining are distinct. m5, m6 and so on. mn are distinct. In this situation, what is this as a solution? First two pair is equal. So corresponding to that, c1 plus c2x into e power m1x. Next, these two are equal. Corresponding to that, c3 plus c4x into e power m3x plus remaining are distinct. So for corresponding to remaining roots, c5 into e power m5x plus c6 into e power m6x plus and so on plus cn into e power m. Here I obtained 4 cases. In first case, all roots are real and distinct. In second case, 2 roots are equal, remaining distinct. In third case, 3 roots are equal, remaining distinct. In fourth case, one pair of roots are equal, 2 roots are equal. Another 2 roots are equal, remaining are distinct. So these cases I written. Here I mentioned that these roots are real and distinct. These roots are real roots. Our roots are 2 types of roots. What are those 2 types? One is real roots, another one is complex roots. Here I said about the real roots. Now we will go through the complex roots. So here roots, complementary solution. Roots and complementary solution. Say this. Complex roots means they are of the form alpha plus or minus I beta. 2 roots are alpha plus or minus I beta. That means m1 is alpha plus I beta, m2 is alpha minus I beta. Remaining roots are real roots. Remaining means m3, m4 and so on. mn or real and distinct. Real and distinct. Corresponding to that. Here for real roots we are writing one solution. For complex roots we are writing one solution. We are all know for these roots. So here alpha plus or minus I beta corresponding solution is of the form e power alpha x into c1 cos beta x plus c2 sin beta x. c1 cos beta x plus c2 sin beta x. Remaining roots are what? Real roots. So corresponding to the real root solution is c3 into e power m3x plus and so on plus cn into e power mn into x. Here 2 roots are complex roots. So alpha plus or minus I beta. Coming to the another case, alpha plus or minus I beta repeated 2 times. So complex roots are always of the form alpha plus or minus I beta. Another pair of set complex roots alpha plus or minus I beta is one set pair. Same roots are repeated another time. That means how many roots here? These are 2, these are 2. 4 roots are over. Remaining roots are m5, m6 and so on. mn or real and distinct. In this case, what is the solution? So these are 2 roots repeated 2 times. That means these roots are equal complex roots. Then in this case situation is complementary solution e power alpha x into c1 plus c2 x into cos beta x plus c3 plus c4 x into sin beta x. So 4 constants came, c1, c2, c3, c4. Remaining are real and distinct. Remaining are real and distinct. Plus c5 into e power m5 into x plus and so on plus cn into e power mn into x. So this is the general solution, and the last case here I am mentioning this. Complex roots are alpha plus or minus I beta, alpha plus or minus I beta, alpha plus or minus I beta. How many sets are equal? 3 sets are equal. Next, 6 over m7 is equal, m8 is equal, m7 is equal to m8 is equal to m9 or real. So I have one solution, I have one equation. That equation having 9 roots, that means 9th order differential equation. So first complex roots for this one and for this one. 3 set of complex roots are real and equal. So for this first one e power alpha x into c1 plus c2 x into c1 plus c2x plus c3x square into cos beta x. Because of that it repeated, plus c4 plus c5x into x plus c6x square into sin beta x plus c7 into, here see this, c7, c8, c9, 3 are real equal roots or real and equal. Then this one c7 plus c8x plus c9x square into e power m7x. Like this we have to write the general solution of the complementary solution of the given differential equation. Okay. So with this I am completing. Thank you.